Good morning, everyone. Welcome to the HPC onboarding course for this spring. So my name is Tanya Pushpadas. I'm the course coordinator at NRIS. So a few words about NRIS. Who are we? We are a collaboration of 4 universities, University of Bergen, Oslo, Tromsø, and NTNU, and Sigma 2. We collaboratively operate and manages the national infrastructures. So we go with the name NRIS, which stands for Norwegian Research Infrastructure Services. And if you can follow NRIS with signing up the Sigma 2 newsletter, and if you are some specific sites like UIB, you have a mailing list to subscribe for the notification of upcoming events and other news regarding NRIS. As you know that from my email, you got the information about the collaborative document we use for Q&A for this course. And that's what I'm sharing. And this contains the general information, links to NRIS documentation and our upcoming event, and the current event page and lesson material. 2 important things. One is, as you might have seen now, I'm recording this event. We plan to publish it after editing. So please feel free to turn off your camera if you don't want to be visible. Anyway, I will be editing it after each day and publish it on Sigma 2 YouTube channel. You will get a link after it is published. And the other thing is, we follow a code of conduct based on carpentries. It's mostly being respectful to each other and being friendly to each other. So it's applicable to both us as instructors and coordinators, as well as you. So this collaborative document, this is for you to ask questions, not on the Zoom chat. We recommend you use this document to ask questions, and how to do that is you go and you see this pencil icon, and you will click on this, and you could see that you could type your questions here. We have asked one icebreaker questions. How do you ask a computer to do something for you? Because we start with the Linux commands the first day 0, and we would like to know your thoughts on this. And below, you can ask question about each session or any other question related to this course material or event. I am from University of Bergen, so you will see most of the instructors from different 4 sites. And I will hand over the Zoom dais to our first instructors, Bjorn and Maikin. Can you take over the screen from me, Maikin or Bjorn? And can you please introduce yourself to the participants? Thank you.
My name is Bjørn Lindi. I work at the HPC group at NTNU. So I've been part of teaching and training for a few years. So I think it's the first time I give this lesson, but I've given other lessons before. Maiken, will you say something about yourself?
Yeah, I will. So I'm Maiken. I'm at the University of Oslo. And I have a background in physics, actually, but now I work in the IT department at the University of Oslo. Yes, you can start, Bjørn.
Yeah. So we will talk about the terminal and UNIX and how to do remote login to a UNIX system. So what you will need is an active user account on Saga. I hope everyone has that. And contact Tanya if you don't have. We can make user accounts in a hurry if it's needed. So the objectives of this 30 minutes lesson is what is UNIX? What's the terminal, a command line? What we call the UNIX shell. Why do we need it? What do we mean by logging into a remote system? And what is SSH, secure shell. When did you start first using Unix, Maiken?
That's probably when I started university in 2003, I would think.
Yeah.
Yeah, I think so. What about you?
I started at a job in the gamle Televerket, the old Televerket in Norway. And then I started using Unix as part of that position, that job. And that's more than 30 years ago.
Yes.
So I have some experience. Okay. I think we'll skip the shared document for now. We will come back to it in a while. So no, well, we can use the interactive document to write some answers. What are the methods you don't know how to interact with the computer? So answering this question in the shared document.
So there's, well, I don't know if that's the tutors or one of the participants, but at least one person has used the command line before, so they will know what all this is about already.
Yes.
But we are assuming that most people really, this is the beginning of their journey to using terminals and Unix.
So what are the methods you know for interacting with a computer? Write down some answers in the shared document to give some exercise to using the shared document. And if you edit the shared document by pressing the pencil or the split to document. The I is just for viewing. We take 5 minutes to do that.
We could also, while people are, typing their answers, we could also continue along a little bit, maybe,
Yeah.
or
Well, I was reading through the lesson yesterday. I was just thinking of graphical user interface as another way of using interacting with the computer. But AI has of course come up now as a new entry.
yes, now you can just basically talk to the computer, and you get
and you
full
get
long answers.
long answers. I didn't think of that.
And of course, when we say, methods to interact and ask the computer to do something, one thinks, one needs to ask orally in some way. Of course, that's not what we do usually. We ask when we're clicking on something, we're actually asking the computer to do something, or when we're typing a command, we're asking the computer to do something, of course. But yeah, people understand that from their answers, I see.
Yeah. So what is Unix? Unix is the operating system that we are using. So an operating system is the software they make the computer usable by it manages the hardware and software and automate tasks that are needed for the computer to work. So types of operating systems are Windows, Mac OS, Android, Chrome OS, and Ubuntu. And there are a lot of Linux flavors. So Unix is much more than the terminal, which is the command line interface command. So that's the interface that interprets text that is inputted to machine understandable instructions. And the command interface is also called a shell. So it's a shell that uses methods for interfacing. There are different variants of shells, and the most common ones are bash and C shell, or a set shell. So with the shell, we get a possibility to script or to program our task with a scripting language. We will see example of that later in the week.
Yeah, and usually one just chooses one, which is very often bash if you don't if you don't have any other special preference, and then you just usually stick with that.
Yes.
So you don't really need to learn the different flavors. There's slight differences to the different programs, shell programs, but typically you can just stick with the one that you choose. And bash is the one we recommend. It's the most usual.
Bash is what comes default on the HPC systems. So why do we need to use the terminal? Well, it's a very efficient way to achieve complex tasks. Let's say we want to rename 1,000 files or remove them somewhere, just to store them somewhere, archive them. We can group a collection of files with a special ending, like PNG or JPEG. We can extract information from files, 10 lines of hundreds of files, and place it in a new file. And we can also work on remote computers, which we'll see in a moment. We often combine simple commands to more complex ones by using pipelines. In this way, we can solve quite complex tasks.
And we'll be learning about that later on, actually, in this onboarding course.
So where do we find the terminal? On a Mac system, you can search for the terminal in the command menu. On Windows, you can search for the terminal on the left, in the left corner, where the search symbol is. And here is on Mac OS. On Linux, it's also often in the menu. So here we see the kind of characteristic of a command. It's the echo command, which then has an argument which is called $0. And this one echoes nothing since the argument is empty.
But this one, doesn't it actually echo the command use?
Yeah, the bash.
Yeah, or
Let's
not
see.
the command.
Let's see what it does. It echoes bash, in fact. The current shell, which is the command itself. That's what's strange. Echo is the command, but echo is a part of the bash shell. is a shell command. Perhaps that's why.
Yeah, I haven't thought about that before,
I haven't
actually, but
thought about that before either.
typically so this is an example of a command, and that you can also pass arguments to it. It can be a word here, or this $sign means that it's actually a variable, and the variable 0 is a special variable. So typically when you pass arguments into a command, the first one will be 1. So the 0, 1 is the special command, and it seems it returns the shell, the command, the shell type.
Yes. And yeah, perhaps we can go back to the shared document and see how people are interacting with their computer with a computer. So we see there's the graphical user interface, keyboard, mouse, trackpad. People use Telnet, SSH, virtual VNC. That's a graphical user interface that's remote. And RDP, I think, is the same. Remote desktop. Virtual machine. Yes, so there are different methods. And if you look at the icebreaker as question, how do you ask a computer to do something for you? Yeah, there are different ways. Ask AI to tell me how to ask the computer. Command prompt, PowerShell, execute a program, click on typing. So now we're going to discuss Secure Shell. Secure Shell is a protocol used to make it possible for two computers to securely communicate over a network. So we had here on the one of the methods that's now mentioned in how to interact with a computer is Telnet. Telnet sends all commands and passwords in plain text over the network. So you can eavesdrop the traffic and see people's passwords and what they're doing. While SSH encrypts the passwords and encrypts the traffic as well. So that's quite neat. You don't want to share everything you do with everybody else. So how do you log into a remote system? First, you check that you have an SSH version. You can do that with the SSH minus capital V. And then you see that SSH installed and OK. So if you get command SSH not found, then you need to install it.
I don't know how usual that is nowadays, actually, but it would be interesting if anybody has that problem, that they, immediately say.
So let's just have a vote on how the installation, or whether people have SSH.
seems to be good. Most people are writing that they have SSH.
Yeah. Yeah. Okay, there it is. Yes. Nobody don't have SSH and nobody's lost. That's good so far. So I'll log into Saga with my username.
And I guess the participants could try the same, or
Yeah, just follow.
yeah, with their
their
username,
username.
obviously.
Yes. Saga Sigma 2.no. So when you then log into Saga, you enter a login node. A login node is like a compute node, but it's a server that are used for submitting jobs, coding, debugging, and not for running jobs or simulations. And you share the login node with hundreds of others. So you have to be very nice when you work on the login node, not to start jobs that eat up resources. So if you write the name the command host name, you see the name of the login node you entered.
Yeah,
yeah, Maiken?
and I was just going to say, if you can scroll up a little bit, Björn, to that picture of the laptop, the internet, and the cluster there.
Yeah.
Yeah, there you see that there is like in the cluster part, that's the whole big infrastructure, the whole kind of computer farm, right? And this
Right.
blue part is probably supposed to symbolize the login machines.
Node, yeah.
So there are a few, like maybe 5 or something like that. And then behind that, where the actually work will be done, is a whole like huge set of more compute nodes or compute, compute nodes, we call them.
Yeah.
Or worker nodes. So those are the ones doing the calculations and stuff like that. But the login nodes are the ones that you arrive at and can do some small commands and testing.
That's right.
We'll learn more about that later.
On the page from the HackMD, the shared document, there's a link to the fingerprints that the different system has. It's also possible so these can be entered into a config file. I'll write
So typically, let's say you've been logged into a system like half a year ago or something, and then you log in again and you get this message in the bottom there, common SSH errors. If you click on that page, please look at this page, Björn. It says, you know, the remote has changed and so on. Looks a bit scary, but it can just be that there's a new fingerprint for the I guess it's when you change the certificates or something like that.
And when they have been the system have been upgraded the last year, within the last year, so they've gotten new fingerprints.
Yes, so it might not be a problem. Just check the fingerprint in the way that it says here, and just follow the instructions in the warning here. You typically have to remove some line in your, it'll be the line that says on your message. in
Yeah,
that file.
There are a file called known hosts,
Mhm.
which exists under the .ssh subdirectory. This is on Linux and Mac OS. So you need to edit the known hosts and delete the entries for Saga if you get connection problems.
Yes, and then you just log in again, and you can check the
Yes.
fingerprint if you want to be sure, and then it should be fine. So now we're gonna go and start working on the system. So we're gonna go to moving around and looking at things now. That's the next class, next episode. So what we'll learn is how to navigate through folders. I'll probably say folders or directories one over the other because I use both names, but I mean the same. And you'll learn how to create and copy and move and rename and remove files and folders. And also you'll see how to learn how to see the contents of files in the terminal and how to compare files. So the session here is divided in two. We're going to have first like a demo where I show things and you can follow along if you want. But then there'll also be an exercise after a little break that you can try yourself. It's up to you if you want to try to type along, if you're comfortable with that, or you just look and you can try it later. So for some people, it gets stressful to type along, others like it. If you want to type along, here is the copy of the commands that you can use. So I'm going to do that and I'll show you how that is. I'll just do one line by line, but you can also click on this icon to copy all these lines and paste it, but I'll do line by line here. So first it's CD, and we'll learn these commands just in a bit. I'm in my terminal in the bottom here, and I am already logged into Saga. So I will just do CD, and then I will do this next command. I'll copy that. That downloads the files I need. I'll do the next command, copy, paste. So don't worry if you don't understand this now. And then the next command, copy, paste. We'll learn more about that in a minute. Okay, so logged into Saga, I've executed these commands, and now we're gonna start the demonstration. So first of all, when you're used to, working on your laptop, on your Windows, Mac, or even your Linux laptop, you come and you see the desktop when you start your machine. But when we log into the remote system, we just see the terminal. So kind of where are we actually when we come in to the remote system? How we can know where we are is to write the command pwd, which means print the current working directory. So that returns for me on this system this path here, /cluster/home/mic/demo moving around. So I am now in the folder demo moving around, which I actually just created with these commands up here earlier on. And I'm in my home folder here, cluster home mic and pair. So that's one way of saying, okay, where am I standing now in my file tree? But we will also want to know what's inside of that folder or directory where I am now. And there is a command for that also, which is ls, and that lists what is in a directory. So let me type ls. Do you see the terminal okay, or is it a bit too low on the screen?
It's okay. It's very nice.
Yeah, very good. So let me type ls. And here you see the files that are in this folder. Okay, so it's exactly the same as in the example here. Printout in the episode material here. If you're somewhere else, you will obviously get something else because you'll be in a different folder with different contents. So for basically all Unix commands, there are many options usually. We call them flags. So how to so you can do ls, but you can do ls with different options there also. And the way that you specify that you want one of the options is to use this dash or minus sign. So let's look at one of the options, which is the long format of listing what's in the directory, ls-l. And then you see that there's more information. We will go more into what all of this means here before, but you see there's something here in the beginning. I can show you here on my command line. There's some information here about owners and so on. There's some time, and then there's a name of the files.
And the size of the files.
And the size of the files, yes, exactly. That's here in the 1, 2, 3, 4th column. And when it comes to the size, that can be a bit hard to read if the numbers get large here. So there's another useful option, which is H, and that's like human-friendly, readable. LH. This is an example of combining. Yeah, actually, that's interesting. So there's a little mistake here on the web page. If you just do LH-H, you don't actually get anything more useful. You need to combine it with the long format. Let's do that again. And then you get what it says here on the web page, that you see that the sizes now are in kilobytes, or they can be in gigabytes or megabytes. So it's easier to read how large the files are instead of a long number here up here. So that's also an example here of what you can do with these options. You can add them together. So there's many options, and with the short dash, you can just put them one after the other together. I can, for example, show another LHR, and where R is recursive, no, reverse order, sorry. And then you just see that they're listed in a different order here, according to their timestamp. So you can kind of add these when there's just one dash. Options, some commands also have options where there's 2 dashes. And when there's 2 dashes, it typically means that there's everything that comes after that dash is the option. So it can be a word instead. Let's see if we have an example. I don't think we have an example of that. But when there's 2 dashes, that whole word is taken as the option, and it's not like a combination of single like L and H.
We'll see an example of that in the next hour.
We'll see an example of that later. So there's going to be many commands that I'm going to show you. So I just wanted to also tell you about there in the bottom here of the contents, there is a Linux command cheat sheet. And here, it's a long page, you have to scroll to the right. There is actually like a list of all the commands that will be using, with a very quick short description of what they are and what most common options are. But also, a very important thing when you work with Unix is that you should learn how to use the man pages. For every command, or most commands, there is a man page, manual. So if you click man ls and enter, you come into a page where you can use your up and down buttons to scroll down. And here you will see all the description, the syntax in the top there, and the different options. Here's actually an option with these 2 dashes. You see it's a word author. So yes. And then how to get out of this, you can click the Q letter, Q. Okay, so let's go a bit further. Let's go from one place to another place. So let's first see where we are. Okay, we're in the demo moving around folder. Let's see what's inside there with ls first. Okay, we have, I have some highlights here of colors. The blue here folders are, the blue are actually folders and the black are files. Okay, so let's say I want to move into the folder called some folder. I do that with cd change directory some folder. Okay, and enter. Then let's check where we are. pwd. Yes, you see that I am in the some folder. And then we can go out again with cd and 2 dots. That means that we go 1 directory above. That means back where we were before. Let's do pwd again. And yes, we're back in demo moving around. So that's one way of navigating back and forth in folders. And you can, of course, go further and further up and so on.
So the dots, dots means parent directory, and 1 dot means current directory.
Exactly. If I do check, so we are in demo moving around. If I do cd dot and slash, it actually just puts me where I am. It's current, it means the directory here, while 2 dots is the one above. I'm losing track of time, sorry. What's
You have 10 minutes before the break, before we'll
Okay.
have a break. So
Very good, thank you. Yes, and you know, very many of the Unix commands have very short names, and sometimes it's not so obvious what they are, what they mean. Others are obvious, like pwd with print working directory is clear what it means. But you know, these names are old. Some, you know, got a name and then everybody started using it. It became popular, and then one realized maybe that the name wasn't so suitable, but it stuck. So I mean, don't be too worried about if the names of the commands don't make too much sense. There is a history there, and it's, you know, you can read a little bit about it. It's quite fun in this link here. Okay, so I told you in the beginning that when we typically open our laptop, we see our desktop. So that's kind of like the home screen when we get into a laptop. But when we log into Saga or some other of the remote systems from a terminal, we come to our home directory, which is not typically a desktop. So there's first of all, different ways to find out, or if names for or commands for what is a home. So first of all, we can print out with echo. Echo means print out to the screen, a variable, which is the $sign now, saying here comes a variable with a name, capital home. So echo print out the variable with name home. It's a special variable, and you'll always get some answer here, depending on which system you are on. So here, I am in cluster home mic and pair. That's my home directory, and yours will be cluster home and your username. On a different system, it might be a different path here, but typically it will always be your username that you'll see. You can also use echo and the tilde sign. That also should print out your home directory. There's different ways of getting to that home directory. You can do change directory and then the home variable like that. Let's do pwd to check where we are. Yes, we're in home. We can do change directory and the tilde, so both of these work. again, we're here. Let me just go into courses. So we see we're somewhere else. And then now let me try the third command to get me back to home, which is just cd change directory and nothing after it. Press enter. I do pwd. Yes, I'm back to home. So these are some ways to first find out what is the path of your home directory and then to get back to your home directory. Okay, so that's good. Now we know how to get back home. We know how to find out what's the home directory. Now let's look at how we can create and copy, rename, move, and remove files. So let's first go back into our home directory and then go into the demo moving around. This is an example here of kind of concatenating two commands. So let me do that. cd and demo moving around.
You forgot that CD there.
What did I forget? Yes, I forgot the cd for the next one. Thank you. That's why I got a mistake there, an error. Okay, so this is an example. You can put one command here and then it kind of does that first and then it'll go ahead and do the next command. You can do this separately also. You can do cd and then you can do cd demo moving around. That's the same. Okay, let's try to make a new folder. That's done with the command mkdir, make directory. And then we have to type the new folder name. In this case, it's going to be new folder and press enter. Okay, let's see if we created that folder actually with ls. Yes, we have a folder called new folder here. So that's how you create a folder with this command here. And then let's copy a file. Copy is done with the command cp for copy, so that's rather obvious. Let's copy the poem into a new file called poem2.txt. So copy poem.txt to poem2.txt. So this will now create a new file poem2 with the same contents. So if you were in Windows or Mac, you would probably right-click on the document or go into the edit or the file and, you know, save as, and you would give it a new name. But here is this is the way you do it on the command line. Copy the original file name and then the new file name and press enter. And ls, just to see if we got a file called poem2. Yes, we did. So right now we don't know yet if this poem2 contains the same contents of poem. We'll learn how to look into files to check the contents just in a minute.
Now we are 2 minutes, 1 minute before the
Okay,
break.
yes. So let's then also show how to move a file. That will not copy it, it will overwrite it to a new file name, poem3.txt. So what happened then to poem2? It disappeared and we got a new file here. And then there is a way to remove files also. Be very careful with this command because you might remove something that you don't intend to removing, and if you remove it on the command line, it'll be gone. So remove poem3.
Yeah. Removing here, there's no bin that you
There's
can...
no bin, so be careful when you type the rm command. Okay, let's see if it's gone. Poem3 is now gone and is not in the bin. It's gone forever. Okay, let me show you the last command, and then the next ones, the other ones will be left for you as an exercise. Let's check, let's copy the poem again to poem2. let's see how we can inspect the contents. We can inspect the contents of a file with several commands here. Cat, more, less, head, tail are examples. We'll use cat for the moment. Cat, poem, text, and you see it actually prints out the contents of the file here right in the terminal. So let's check if poem2 contains the same text. Let me just expand a bit. And yeah, it looks like it contained the same. Let me show you a quick other command. Diff checks the contents of the two files to see if they're the same. It gives you no difference, so they are actually identical, as we were expecting. Yes, I think for the other commands, you can try them yourself in the exercise after the break. And more and less works in the way that the man does, that you have to kind of scroll down, and you can use Q to get out of those commands. I can show you quickly more like that. I can use enter, or I can use the down key, and I can use Q to go out. The letter Q button.
So
Yes.
now we'll have a 10 minutes break.
Yes, very good.
Is it okay? It's you see finding things on my terminals.
Yeah, you have a co-instructor, Sabri,
Yeah.
right?
So
Yes,
we'll
hi.
Sabri, could you say something about you so that everyone knows? I know you are having sessions tomorrow as well.
Yes, thank you, Dania. I'm Sabri, joining from University of Oslo. I'll be assisting you on, Bjorn on this lesson. Yeah, go ahead, Bjorn.
Thank you.
Yeah, so now we're starting to work in the terminal with files and subdirectories. As we add more and more files, things start to get complex, and the question is where is everything stored, or where is our files? So we'll discuss now how we can find files in complex folders, and we can also how can we find special content in these files. And we have two commands at our disposal that we will be using. That's grep and find. Find is for finding files, and grep is used to search within the file. So I'll need to download the examples. CD.
So Bjorn, should I just copy paste what's in that box without knowing what it does actually?
I think so. We can just copy it what's in that box. Copy it like I do. And the command here we get is for downloading the file, and command tar is for tape, stands for tape archive. So we extract the subdirectory from the tape archive finding things tar.gz. Like that, then we should be ready to find files in folders with find. So we'll try to find a file called output text in one of the, which is supposed to be in one of the subfolders. And we're using find. And find has kind of two parts. It has the starting point and the optional part. If we'll look into man.find, we'll see this as well. That the find has a starting point like this, and then expressions for what to do from that starting point.
So just to remind beyond that, when you come out of the man pages, you have to press the Q in the keyboard.
Yeah, that's right. I pressed the Q. So finding things minus name output text. This will search the subdirectory finding things for search for the file output text in the subdirectory. And there it is. It's under finding things, GOD CJRB v/output of text. We found it. We can add an option, iname, then we will be searching, then the name is case insensitive, so will search for output of text both in capital letters and in small letters. Finding things minus iname output of text. This gives two files. The first one that we found, and finding things AIVXIEVNFEIPOOGD output.text. We can also search for all the files that ends with CSV, search for all the comma separated files that are in this subdirectory. We write finding things minus iname, and then an asterisk match asterisk .csv.
So beyond here, I would think that including this file name with asterisk inside quotation is very important to get the uniform results on different versions of Bash and other terminal shells. Yeah, and I see that you correctly included that in a quotation.
That's right.
And what does the asterisk mean, actually?
Asterisk means you match 0 or more characters with the asterisks.
We also called it a wild card. I don't know if that helps
yes.
for people, but
Yes.
anything can go in there.
So we see we have several comma separated files in this subdirectory. And we use the flag minus iname, so the if there was CSV files in capitals ending with capital letters like capital C, capital S or V, then we will catch those files as well. So let's create a totally new file. Touch is a command that creates a new file with the current timestamp.
So I guess for demonstration purposes, you just needed a file, any file. So you created an empty file with the command touch.
Yeah. So here we see it got today's date and the current clock, 10:30. So I'll use this as a part of my search. So this file is now much newer than any other files we can find with either the rmin or mmin option, depending if you're looking for access or modification time, respectively. So finding files that we have accessed them last 10 minutes.
Finding, I think your spellings for the directory name that you're searching.
No, I think it's
wrong,
the
yeah.
minus 10 here.
Okay.
No, it's not.
The name of the directory. Yes, now correct. So in that output beyond, I see that you have more files, not just the file that you touched, which I think is because we just downloaded it, the files. So you just did that, so it's showing more files than it should, isn't it?
It does, yes.
Okay.
So finding files that have been modified, that are more than 100 kilobytes. You can use find again, finding things, minus size, 100K plus 100K. Lists almost all the CSV files and some additional files. And then we can combine arguments. So we can list CSV files that are more than 200 kilobytes large. Find things, minus name, CSV size plus 200K. So there is one file that's larger than 200 kilobytes. So this the command find is then for working in the subdirectory with the files. We can also combine it with grep to search for content. So let's see here. We have the file gene list TSV. So we'll use this path to look at the first 5 lines of the file. So we see that the file contains genes organized in 3 columns. The last one describing the organism. So we'll use list all the genes from rats. We can use grep to search for rat. This results in 1 line. You can search for here as well for to ignore capitalization by using the -I flag. Grep -rat finding things gene list TSV. Then we have 2 entries. And more, can you explain this grep command, Sabri?
The grep command with -C is what you mean? Or
with the -RHSD finding things. What's going on here?
Sorry, Björn, I just lost a little bit. Is that the command that you typed now, or is it?
Yeah, the command here.
Okay. So it's going to go and find things recursively in the content in the folder, but it's also going to print 1 line before and after what it was matched.
Okay.
So if you press enter and if you press enter, it'll not only find what's matched, but it will also print the line which was before and after. In most of the time, like if there is a line before and after. Some of them, yes. If you scroll a little bit to the top, the first finding. So the first file, the name of the file is sequence.fasta. So in that file, it has found 2 matches. The first one is actually what you're looking for, the text which says HSD something, and the line below. There is no line above, which means that is the top part of that file. We could have a look at that file and see. But on the second file, gene list, what actually matched is line 223, which is that HSD 17, the gene. And it has also printed the line 222 and 224, which means that, it's in the middle of the file somewhere. The same case for the notes.txt.
Yeah. So we can say we can have very advanced grep commands that search for text in files. Okay, so now it's 15 minutes exercise. So
Björn, can I mention something that related to what Maiken mentioned earlier, sir? So these Unix arguments, if you use single dash, which means that the characters you're going to type, they'll be taken as a separate argument in some cases. For example, ls. If you say ls-lh, means it's as same as ls-l space -h. But in this find command, we use the single dash.
Yes, bad.
Yes.
Confusing.
so if you type find dash name, the find command will take all 4 characters as one instruction, not 4 instructions. But on ls command, if you give the same instruction, it will take as 4 different instructions, not as a single instruction. So I think with usage, it will become more apparent, and it's also related to the historical nature of Unix, what Mike mentioned. It's older than all operating systems, but it's still being used. So you will find things like that. Be cautious when you see those, and use the man pages as beyond, and also Mike can show.
Thank you, Sabri, because I realized that afterwards that that's the case. Thank you. Let's get back to the next episode, which is the create and modify files. And so it was mentioned in the collaborative document, and sorry for not explaining that before, but this right window that I have here is just, as was explained there in the questions, is just a history of the last command that I wrote. So let's go into create and modify files. So the intention here is to teach you then several ways to create or modify files without leaving the terminal. And why do we want to teach you that? Well, the reason is that if you open like a kind of a graphical user interface, like some nice application that you typically use on your laptop to edit files in like a Windows kind of system, it will be slow when you're working remotely. So you can do that in some cases. They allow that you open like a kind of Windows application, a graphical user interface remotely, but you'll probably get annoyed and not want to do it anymore because it's slow. So that's why we find it handy to be able to create, modify, and edit files in the terminal itself. So we're going to learn about what is a terminal text editor and how to view a file content. We've learned some things of those things before, so some of it will be repetitions here. Okay, so let's get to the first example command that we will be using, and that is echo. So we've already learned what the echo command does. It prints out some information for you, or prints out, for example, if I do echo hi, it'll just print out hi for me, okay? But now it's printing to the terminal. So how can I use this to write something into a file? Well, then you can use redirection, okay? So here is an example of how to do redirection. You type the echo command, you type what you want to print out, in this case, created with echo, that's string. And here comes the redirect sign. It's a larger than symbol. And after that comes the file name where you want to send this text into. So let's just try that first. So let's write echo and then double quotes, created with echo, close the quote, the larger than sign, and then a new file name, new file with echo.text, and then press enter. Wait, I misspelled it. Let me do it again so that we actually have the correct file. Let's clean up. So these are some extra commands now because I want to remove that wrong file so it is clean for us. Okay. So
Just
let me do
a reminder using ARM. I always do that.
Remove.
Remove.
And be careful, but because it actually removes the file, you can't get it back again.
Yeah, you cannot find it in your trash also. So if you
Yes.
do it ARM on terminal, that's deleted forever, I would say.
Yes, exactly. Be careful with the RM command. So ls. Okay, so now I am here and I see that I have a new file with echo text created. So this shows that if there's no file there from before, this file didn't exist before, it will create that file. And be aware that if there is a file already with the name, this command will actually overwrite what's in it. Okay, so we'll see what to do about that in 1 second. But let's inspect the file now. What's inside the file? We are expecting that the string created with echo is inside. So let's use the cat command and new file with echo, and then enter. And indeed, it's as expected, the string created with echo is inside that file. Okay. So now what if we want to add more text into that file? Then we use 2 of these symbols, 2 of the redirect symbols that will append to the file. So let me try that, echo, and then a new string, last, of course, this string can be whatever you want, but with echo, and then 2 of those redirect signs, and then let's write it in again to the same file and press enter. Now let's inspect the file again and press enter. And indeed, we have 2 lines created with echo and last line added with echo. It'll append it to the end of the file. Now, let me show you what happens if I now do the first command again. So echo, let me just write a new line. So a new line. And then let me use 1 redirect and then the same file name. Let's inspect the file and we'll see what is inside it now. Okay, so we see we overwrote what was in the file before. We had these 2 lines before, and now we only find the new line that we added. And that's because, as I said before, be aware that if you just use 1 of the redirect signs and the file already exists, it will overwrite it. Okay, so now another way to create files with contents is to use the cat command. It can be used to view contents, as we've seen before, but it can also be used to write text into a file. And it kind of records what you're doing. So we try now cat, and then the redirect symbol, and then we'll create like a new file with, now it's called the new file with cat.txt. And let me press enter. So what's happening now is that we have a cursor on the line underneath, and it's actually waiting for us to type in text. So let me write A, press enter, let me write B, press enter, let me write C, plus enter. Okay, I'm done. So I want to stop recording what's going into the file now. So I'll press Ctrl and D to stop. And let's then inspect what is in the file that we just created. And it is ABC. Okay, as expected. Good, it worked. Another thing we can do is that we can first display or read everything which is in one file, and or several files actually, and we can put that into another file. So in this example, we want to put what's in file 1 and file 2 into the combined content. Just sorry, I want to scroll up to see it now. It's fine. So let me just see what files I have here again. Okay, so let's now do cat new file with echo, and then let's also do the new file with cat, and then let's try to put it into a combined content file and press enter. And let's inspect that combined content, and we're expecting that it should be ABC, and we're expecting that it should be this new line string, because that's what we have in these two files that we just used. And it did. So first is that string that we had in the new file with echo, and then afterwards it's those lines here with cat that we tried just before with cat. So that's two handy ways of adding contents in a file. So what's the time and how am I doing?
We have like 12 minutes, but you can go 2 more minutes, 14 minutes, I would say, since we started late.
Okay. Good. So these are like some basic commands to work with files. They're very handy, but sometimes you would like to write text a bit more I would say, comfortably. And then what you can use is a terminal text editor. There are many, of course. So what it is it's a text editor, like Word is a text editor, and the text edit on Mac is a text editor. There's many text editors. This is a very simple text editor that we're going to use, and it lives in the terminal, opens in the terminal.
Yeah, so we use it tomorrow as well when we work with the remote system on Saga. So this is a trial for that, for you to edit JavaScript tomorrow.
Exactly. So this is a good thing to try later on if you don't try it now in the moment, for preparing for tomorrow. So yes, what does it say here? Yeah, some examples of some different terminals like V or Vim. This is similar to, I guess that's what gets opened when you're using the man commands, I think. And it's a bit annoying if you're not used to it, because you don't, you already had the problems getting out of the less or more or man pages. You have to type commands, and it's not so easy always to know what that is. Another text editor called Emacs, that's one I typically use. And then there's Visual Studio Code, which is also possible to use. And there's some links here how to use that. So these are just examples, other examples. But now we're going to learn how to use a nano editor. That's a very nice editor to use if you're new to this, because it gives you a bit of help for what commands to type to do what. And it's installed in all our clusters from Saga and everything. So let me then open that, and I'll open with nano command to open it, and then I'll give it an argument. So this second here, string here is the file name that I want to open it with. And in this case, it didn't exist before, so it'll create it. Okay. I'll show you later also, if you open just nano without any file name, nano will help you in that case. So what do we have? Okay, we have, you see GNU Nano is the name of the text editor, a version, and here is new buffer. I guess here there's one opened it without maybe a file name. In the bottom here, you get some help for how to tell Nano to do things for you. This hat means the control key, and then, for example, hat X means control X to exit, and hat O, write out. I guess it saves the file for you into a file name, and so on. So let's just try to exit first. I'll press Control X, and it just exited. I'll try to go into Nano again. Okay, now I opened it without any argument. So this file does not now have any file name. So let's see if I want to save this file now. Let's do Control O. Okay. Now you see that it says file name to write, and it's empty. So it's waiting for me to type a name. So let me then type file with nano.txt. It doesn't matter if you say .text or whatever. It's just a way for us to know it's a simple text file. And I press enter. Okay, then you see that it changed here to the file name, and now it's ready for my text. So to write text, I just write some text here. I can use enter for changing the line, some more text, etc., etc. Okay. So you see, it's very simple, just a very basic text editor. It has what you need to write files. So let me then also now try to save this file. So let me write Control O to save it. Okay, so since I opened it with the file name here, or I previously saved it with the file name, so it's suggesting the same file name. And I could choose to save it with that file name, or I could choose to change the file name so you get another file, a new file. I'll stick with the one that I have and press enter. Okay, then I've saved the input there. So there's many other commands to try. Let's say I want to cut the whole line here. Let's say I want to remove this line. So, well, we can use Control K to cut. Let's try that. Yes, the whole line got cut away. That's handy. Let's paste it back. Control U. Yes, it's back. So, and so on. Many things to try. Let's save it again. Control O. Yes, press enter. And let me try to exit again. Okay, so let's see now what we have. Let me see the latest file that how strange it's. Yes, like that, sorry. So I'm adding some options here now to see the timestamp, the T and the R to the LS command. So I have a long format, human readable. It's just how I very often use the LS command. R for reverse order and T for time. Then I'll find my last file here at the bottom. I find that quite handy sometimes. So let's just use cat to check the contents of that file to see if it was what we were expecting when we had nano. And yes, write some text, blah, 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 etc., etc. Yes, that's what was in the file, in nano. So do you think there's something else that should be mentioned, Danya?
That we are going to use it tomorrow as well. So
Mhm.
it would be nice if we could have some trial today afternoon after this event. And
Yeah.
there are instruction about the different options on Nano. Maybe if you want to learn more about Nano, you can use the man pages just like you use other Linux commands.
Yeah, I just want to, when it comes to man pages, sometimes it feels a bit annoying to read it in the terminal. I think all pages actually have man pages on the web also. So man nano, for example, like that. Yes, you can click on that and you can read it in the web page instead. So
Yeah.
whatever you prefer.
Yeah, and when you learn something new, it's not always easy to remember everything. Everyone has this problem. So don't be discouraged to learn the new things. And when you practice things, you will have this sit in your muscle memory.
Exactly.
Are you using Nano for long, Maiken?
I never use Nano. I always use Emacs.
Okay. Yeah, so that Emacs is another editor. That's if you want to use it's one's preference using an editor. I always use Vim.
Yeah.
So
it's just, typically when I started the university, that's what we got recommended. So I just stuck with that, and yeah, it serves the purpose, and I don't see any need to change. So it's good for me. I'm used to all the shortcut commands in Emacs, so I just stick with that.
Yeah. So there are not many questions about this session, about is there a way to systematically prevent incident when entering commands? Okay,
Prevent
that
incident, what does that mean?
probably some deletion, RM probably.
I think that's maybe too of a general question. The danger when you're writing Linux command is that you might be writing commands that are doing something different than what you're expecting it to do. So one thing that we will learn later with piping is that you should always, if you, for example, have a long command, a set of commands with many commands after each other, do one and one at a time and start building it up at a time. And then, for example, if in the end you're removing files, do not do the remove, do echo, for example, instead in the end to just see what's happening. But we'll actually talk about that in one of the later episodes today.
Yeah, so we have set the stage for the composing commands with pipes.
Yes.
And I think Radovan is joining you in this.
Yeah, and the -I here for RM for the remove is very useful. It's interactive, so that means it'll ask you, are you sure you want to delete this file?
Fun to be here. Hi, everybody from UIT, University of Tromsø, where it is currently snowing. And the weather is a really good weather for us to stay inside and learn something about Unix commands. And I will do that with Maiken. And we are now, so the later episode that Maiken talked about is actually now, which is we will be composing commands with pipes. Approximately half an hour. There will not be an individual exercise session, but there is an exercise which we will try to do together. The best way to participate is to ask lots of questions in this collaborative notes. I will be watching this document, Maiken will be watching this document. We will, if there are general questions of general understanding, we will lift them up. The more questions you ask, the better, and the more fun it will be. And I will now go into this episode, which is listed here in the bottom. And I will start first on the web page, but in like 1-2 minutes, I will switch over to the terminal, and then we will be really working hands-on on the terminal. And let me know how the screen share is, and I'm hoping I'm sharing now the course material. I have a bit of an interesting technical setup, so not completely sure what I'm sharing, but I think I do share the right thing. So we are now in the lesson composing commands with pipes. This is incredibly powerful because we will learn how to put different commands together. And with this, we can create basically any command we like. I will zoom in here just to make it easier to read. So how can you follow? Please ask us questions on the notes. I will be typing here, and what I will try to do is in a moment, I will run these 4 commands on the Saga cluster. And if you want to type along, you can run these 4 commands, and then you will have this example also in your home directory, and you can try that as well. But you can also just watch. So I will run that in a moment. But first, I want to tell you where we are trying to go with this. Just as a reminder, there are 2 commands that we'll be using quite a bit, and they were mentioned earlier, but I want to remind ourselves what they do. One is find, and one is grep. They are very, very powerful. And can you recall what they do? There is a solution in here. Let's see what the solution says. So find can be used to list all the contents of a subfolder. And grep can be used if I look for something in a file. And here we will learn how to put them together, how we will compose them. We will learn a couple of other interesting commands, but I will do that then in the terminal. So I will now scroll up here, and I will leave this page and go to my terminal, but I will really follow this page almost literally. So if you get lost on the way, And if something went too fast, you can find it here on this page. But I will now move over to the terminal and run these 4 lines. Now I need to change my screen share. Just a sec. I change it to this one, which is, now I'm hopefully sharing something that has a dark background. It's pretty empty, but we will fill it with something interesting. I'm here on Saga. And I can run a couple of commands. And what I will do here on Saga is I will run these 4 commands from the other page. I copy pasted them here. They download this exercise directory for me, extract it, and move me into it. Let's run it. So you can do that or not. You can just watch me. Now this, I wanted to say a few words here about this terminal. It looks maybe a little bit different than other instructors. I prefer to present with dark background, but let me know if that is not readable, then I will switch. Maybe I have different colors than you have if you run these commands on Saga. And this is, I changed this so that it's easier for you to follow, easier for you to read. I also wanted you to know that it's actually possible to customize it. We will not show you how to customize it, but it's good to know that it can be done. And on the top right of the screen, there is a yellowish box, which is not on your terminal, but we customized it this way so that you can see my past commands. Whenever I type a new command, it will show up there. And we hope that it makes it a bit easier for you to follow. Good. And now what I want to do, I want to show you a couple of new commands, but then we want to do command composition. And here I'm really following the page. So let's, what is inside here? Let's do an ls. There is a folder, calculations, and then there is a text file called RGB, red, green, blue, .txt, and then there is another file called repetitive. And we will try to do some exercises with it. So first thing I want to try is the grep command. Now, our first command that Maiken showed us earlier was cut command. Let's see what is inside this RGB file, cut RGB. The cut command will show me the content of the file. It will not modify it. So inside this file there are colors. They have different names, dark blue, lavender. And these codes here are one way to express colors for computers. So this is hexadecimal notation for color codes. And now I can do a few things. For instance, I can do, I just want to make it more readable. Can you please show me all colors that contain the word blue in this file? And here they are. So there are many, many colors that are blue. We have seen this command before. Now I will show you a new command, which is called sort. It can be, this you can use to sort the content of a file either alphabetically or also alphanumerically. Here we will sort it alphabetically. Let's see what happens.
I guess
Yes.
alphabetically is the default if you don't tell sort what to do.
Right. So normally alphabetically is fine unless you sort something which starts with names and also numbers. So here we want it alphabetically and it looks like it worked. Okay, there are some really funny looking colors. Then the other thing the other command that I wanted to introduce to you, but I want to first show you what is inside this repetitive file, cut repetitive txt. There is some repetitive text. some text, then another repetitive line. And a fun command is unique. Unique will remove consecutive repetitive lines. So if I run this on unique repetitive, it will remove the repetitions, but only the repetitions that are close to each other. Okay, so we learned sort, we learned unique. I want to show you one more command, and then we will try to put them together. The command that I want to show you is word count, WC. You can run it on any of these files, and it will tell me how many words are in there. And now I don't exactly remember which number belongs to what. I think this is the number of words. Maybe it's the number of characters. What I use more often is a word count minus L, because that tells me how many lines are in there. So the first number is the number of lines. So this file has 24 lines. But now let's try to put this together. And what I will do is I will search for extract all colors with the name that contain the word blue in RGB text. But now I will use this pipe command. Pipe command is the vertical line. On my keyboard is somewhere on the right side. So I can take the result from this command and pipe it into a different command. Into this one. What did this one do? It counted the number of lines in a file. So the result from this will be the input to this. And what do we expect? It will tell us maybe how many lines in this file contain the word blue. 136. So there are 136 colors, blue colors in this file. The essence here is not to remember this command. The essence here is this character. This is so important. So we can output the output from one into another, and we can even chain these further. We will do that in a moment. I'm just having a look here.
So repeat that again, Radovan, because this is essential. So you get output from one command, and that pipe, what does it do again?
Yeah, let's try that again. So I could do just this command, the grep, which would put the output, the result onto my screen. Here it is. But if here I decided I don't want it on my screen, I want to pipe it into a different command. This command counts the number of lines. So when I did pipe into another command, it counted how many of these were there. And now if I wanted to, I could pipe, instead of having the 136 on my screen, I could pipe it into yet another command, which would then do something with the number 136. I will not do this now, but we will do that soon. If I now have a look at our episode, it talks about writing to a file or appending to a file. The nice thing is that Maiken has explained this really well in the previous episode, so I can just use it. I don't have to spend too much time on it. But it's a nice recap. So now instead of having this on my screen, I can write it into a file, and I can call the file, for instance, blue colors. And now there is a new file called blue colors. This one. And we have also seen, just a recap, that I can also do append to a file. Let's create another file called colors. I will first call it the red ones, then the blue ones, but now I have to be careful, because if I'm not careful, I will overwrite the file. So I need 2 of these larger signs. And I will also take all the green colors. So if I would now open up the file, there would be first all the blue colors, then first the red colors, then the blue colors, then the green colors. But now let us chain multiple commands together, and let's see what we can do with this. I will type here a command, and let's see what it will do before I execute it. Grep line in repetitive text. Before I hit enter, what do we expect? We expect that it will put all lines that contain the word line from that file into my screen. Let's verify, enter. Yes. But now I want to pipe it into something else. What should we do with it? Well, how about we sort it? Let's pipe the result into the sort command. What do I expect to see? I expect to see that it will probably put first all of this line that is another line, and the two of these will probably be at the end because there is a Y here, which is alphabetically later. Is that really true? Enter. Yes. And now we remember that there was this interesting command called UNIX, which will remove duplications. So what do I expect now? I expect to get, it will probably remove all the duplications from here and only print one. And it will also print only one line for these two. Let's verify. And if I wanted to know, I could even change that. I could pipe it into this. How many lines are there? 2. We expect to see a number of 2. So we just constructed a new command by composing commands. And this new command could be used to find out how many unique lines are in this file that contain the word line. And in Unix, Linux, the philosophy is that there are many commands that do one thing, and they do it really well. And I can combine them to do basically anything I like. And I know maybe 10, 20 Unix commands. I don't know much more than that, but we can compose them to create new combinations. So let's have some more fun with this. One command that was maybe shown before, I'm not so sure, was history. History, enter. What it will do is it will show all the commands that I typed today and yesterday and the days before. Enter. So here are all of them. So if I don't remember one of those, I can find them in my history. And something I use quite a bit is that instead of putting the history onto my screen and looking through all the files, I can pipe history into grep. So if I remember, there was a command, something with sort, but I don't really remember anymore. But it was long, and I typed it a few days ago. Search through my history, take the output from it, pipe it into grep, and now filter out all the lines that contain the word sort. Yeah, so today is April 9. I did a couple of those commands today. So this can be really useful. For instance, if you, we will tomorrow learn how to submit calculations with a command called sbatch. And if I don't remember anymore, what job did I submit? So tomorrow this will be incredibly useful. History, grep sbatch. Yeah, these are some calculations I was running in April and in February. Okay, we have 12 minutes left. Let's have some more fun with chaining commands. And one very powerful combination is find and grep. To locate files, so here I have an exercise folder called calculations, and inside there are lots of files. Let's look at them. One command that was mentioned somewhere on the notes, but not sure it was really demonstrated, can be fun. Three calculations. It shows you the file tree for a certain folder or subfolder. So here we have a couple of calculations in there, a couple of file names. And now maybe you want to know where are all the file names that contain the word error. And we have seen the command find before. I could do find calculations. And it will list all of these. But now let's use the pipe. Let's pipe the output into grep. Please show me only those that contain the word error in the file name. Here they are. And I'm just looking at the notes and I'm looking at the time and thinking of what we will do next. We could go through this exercise together. And with this, I can then show you a couple of commands, and then we can also discuss some of the pitfalls and good practices. So I'm now looking at this. I know I'm not screen sharing it. The green box called exercise solving typical tasks with compositions. But I will now here repeat the questions and we will try to solve it together. So number one was to download and extract the exercise folder, which I have done and which I have. And now exercise step number two, find all files that contain error in the file name. I have done that. And just for completeness, I want to say that there is also an alternative way to do it. In Unix, there are also, often many ways to do the same thing, to achieve the same thing. And the other, because that was demonstrated earlier, so if I don't want to use grep, I could do it just using the find command with the name. I think that was shown before. So here it will filter by the name. The result is really the same. But here I like this solution because I like command composition. Step number three, from the file rgb.txt. So we have this file rgb.txt, and our goal is to create a file called sorted red colors with only the red colors sorted alphabetically. How do I get only the red colors? Grep red rgb.txt. And here I will try to build up this command step by step. So when I work, I often want to verify, does this work? Do I get only the red colors? Enter. Yes.
Yeah, and this exactly is what we were mentioning before about being safe on the command line. So build it up step by step.
Yeah. So that seems to work. And then I was supposed to sort them. So let's sort them step by step, alphabetically. Seems to work. And then I was supposed to write them into a file called sorted red colors. Good. And if I wanted to verify that, I can do cat sorted red colors. That worked well. What was then? What was the exercise step number 4? That was to find all names that contain an error in the file name. We've done that before. I will go here. And now let's do a little bit of repetition here. How was that? So I remember that there was this command, history. I did that sometime in my past. History, grep. There was a find command. Here we did that. But now we need to take that a little bit step further. So find all the names that contain error in the file name, but we now do something with it. And that is for all the file names, for each of them, print the last line. That can be useful so that maybe the last line is contains the reason for the error. But now I'm too lazy. I don't want to open up each of these 3 files. Imagine you have 50 of those. I could open them up, have a look. What was the problem? Here I want to print the last line of each. So we need to change, we need to pipe this into something else. And there is a really powerful command called xargs. I just want to make sure that this is also what we have been showing in the solution so that I don't show something different. And xargs is take what came out of here and apply a command to it. Tail. I will run it and I will explain it. I'm not sure actually we showed the tail command. So let me run this. And so for each of these files, this is the last line in each file. Here we ran out of memory maybe. Here we ran out of this quota. Here we timed out. And if you have never seen the tail command, you can use it to show you the end of a file. If you don't give it any arguments, it will show you maybe the last 5 lines. I don't remember, maybe 10 lines, 5 lines, or 3. But you can give it a certain number. So if I only want the last 1 line, it's this. And now we understand maybe a little bit better what happened here. List all the files, keep only those that contain error, and then pipe the output into the xargs. And xargs can take it and apply any command to the list of files. It can be used to rename files or remove files. Be really careful what you do with it. Something I like to do is if I go back here to this command, is before running it, if I'm unsure what will happen, what if I put an echo in here? I like to, with the echo, I like to see what is the command that will be run really before running it, especially if I have a move, remove, something dangerous here. So this can be really good practice. And I wonder, because we have only 3 minutes left, whether I should switch back to the notes and tell you where you can go from here. I will do that, just a sec. So now back to the notes. What I have shown you, and I really encourage you to try it out in your own time, is to go through this exercise. What we haven't done now is actually step number 5, is it can be also interesting to find out, to list all the files that have error not in the file name, but inside the file, without going through all of them and without opening them manually one by one. I really encourage you to do that. Here is a solution. It's always only a solution. In Unix, there are many solutions to a problem. And then we have some advanced example here, which we will now not go through all together. And that is an example of how to rename many files at once safely. And the keyword there is, again, step by step, using the find command, piping it into xargs. But before running commands, first verify with echo what they do. So we build it up step by step. We do first find. And then before running an xargs command, I always like to put the echo in there to see what will it do. In this case, and then once I'm sure this is really working, then I remove the echo and rename all the files. And if I scroll down here to the end of the page, so what we wanted you to take away from here is that in Unix, the philosophy is that you only really need to remember 10 commands maximum. I don't think I know more than 20 commands. They all do one thing, they do it well. They do one thing only. And you can compose them and achieve almost everything imaginable by composing commands. And in Unix, the approach is that it lets you assemble commands for your use case instead of giving you programs that do everything. So instead of commands that do everything, it's commands that do really only one thing. We have seen sort, it just only sorts, and find, it only lists files. At grep, it only filters. Okay, I'm opening up the notes. Question 28, how far in the history can you look? You can configure it. So there is a default, and it's probably 500 commands, but if you want more, you can change it, and you can have thousands of 5,000 commands. Something we have in the notes is that you can decide whether you want a timestamp in your history or not. Have a look in our notes how this can be done. And I'm out of time. So I don't want to eat into other episodes.
Yeah, thank you
Please
so
ask more
much.
questions.
Thank you so much, Radovan and Maiken. So we will move the last to the last.
Okay, so now we're gonna learn about scripting. We're gonna go to the scripting episode here. And our objective is to save one or more commands, because let's say you have a great routine of sorting and finding text in files like the other one showed before. A complex set of routines, maybe several ones after one another, and you want to share that with your colleague. Then it's handy that it's written up in a file, basically, and that's what we mean with scripting. So it's to make computer work more automated and reproducible, and they can be used just as regular programs, actually. So not only for sharing with colleagues, but for yourself tomorrow, if you want to do the same command again, the sequence of commands, you've saved it in a file, and you can just execute that file instead of having to type it all again. So that's clearly useful. So again, if you want to follow along, we have material that can be used here. So let's copy it again into the, I think maybe I already have that. No, that's good. Into the terminal, and let's go into that folder. And here we are in the Finding Things folder. So in this sequence here, the last change directory into the Finding Things is missing. So if you want to follow along, also add that line there. Okay, so now we're set up. Creating a bash script. We have showed you as I said, ways of composing commands, and we have many different commands. Now we want to save that into a file. So in the finding things folder, there is a file called list.sh. So let's have a look at what's in that file with cat. Okay, so this is the contents of the list.sh file. First of all, in text files like this, all the lines that start with this hash sign, this sign here, are comments. Except for this first line, it's a comment, but it means something special. It has a hash and an exclamation mark. That's a special line, which is called the shebang. I don't exactly know how people pronounce that. I say shebang. And that tells Unix what kind of program this is. So it can be a Python program, for example. It can be a Perl, other kind of programming languages. In this case, it's a bash script command, like bash commands in this script here. So that's a way to tell Unix that this is a bash script, okay? So that will be useful later. And then there are some commands following here, echo, and then some string, pwd, and ls. Okay. So what we want to do now is execute this script, basically run all the commands as though we were printing them on the terminal, but just by executing the file. So we can execute it by typing the command bash and then the file we want to execute. So let's try to do that. Bash list.sh and enter. Okay, so it actually now went through here. It ignored more or less, or the comments. You don't see any output from the comments because those are comments or the shebang. But what it does is first it did the echo command. So yes, here is the output echo. And then it did pwd. Okay. That's print out the current working directory. And I am standing correctly in this finding things folder in my home folder. And it's also listing all files that end with PDF. So let me check by doing this on the command line. So pwd, yes, I got the same result. And if I do ls*.pdf, yes, I got the same results. So you see, you've written them up in a file, and this can be whatever, however long, of course, and it'll execute those files as though you're typing in them on the command line. So that's one way of executing a command, okay? In this case, I have to know that it's a bash command, okay? A bash file. If it was Python and I wrote bash and tried to execute the Python script, I would get in problems because bash does not know how to interpret the Python commands. So then I would have to write Python here instead and then the file. But we can help out a bit here, okay? By making the files executable. So when we make the files executable themselves, it means basically as in Windows or in Mac, when you click on something, it might execute the command. So basically here we will be able to kind of type the file without having to write what command to run it with, and it should execute it automatically. So let's try first to just type the file name, list.sh, see what happens. Okay, it says bash list.sh command not found. It doesn't know what to do with this one. Okay, so that is let's see, let me just read what we've written here about this problem. I guess basically it just don't know what to do with it because yeah, sorry. Now I recap myself. I remember. Okay, this is a bit of a complication because if we just write the file name like this without adding the full path, Bash expects to look for executable files in certain places, okay? And in this case, our home folder is not that certain case, so it can't find the command basically. So if we instead give the path by doing dot and slash and list .sh, we should in principle be able to run it because we're saying giving the full path here. In this case, you still won't, and we'll tell you why. Okay, it says permission denied. What does that mean? So as you see, there are some steps that you have to take in order to be able to run this as a command. In this case, what it means is that we have not made that file executable. Okay, so let's see what that means. Let's do ls-l as it is explained here on the web page. And then let's look at the list.sh file. Okay, there's a lot of information here. We've seen this printout before, but we haven't really explained in detail what all these columns mean. And it's the first column that is the most important for us right now. The first column here tells us what permissions this file has. And it's divided into blocks here, or sets. I can mention first, which is not essential for us at the moment, but some of them have a D in front. That means that it's a folder or a directory, okay? So, but for the list.sh file here, there's no D, it's just a file. Good. So then we have three sets of 3 characters here. First 3 is these 3, and then there's these 3, and then there's these 3. And the first 3 set is what permissions the owner of the file has. And it can be read, R, it can be write. You can write the file, edit it with W, or you can execute it. And that is an X for execute. If you look at the file a couple of lines below, you see it has an execute here bit. But the list.sh, me as the owner, I can write to it, I can read to it. Now, who is the owner? That's me, Mike, and Per. You see it here in the second column. So that means that I can read and write, okay? And then the next column here is what group is this file written as. And in this example on the web page here, it is in the group NN9970K. It's a project group, okay? Because exactly for this example here, I created these files in a project folder. And that means that for the set 2, all people that are in this group, maybe Danya, Sabri, Radovan, and Björn are in this group. They have this project together with me. All of those people can read only, but they cannot edit it. They cannot write to it, and they cannot execute it either. Okay, in the example here on my terminal, this file I created in my home folder, and here only me, my personal group, I can read and write it, and only me also can read it, okay? So that's an example of how the different groups will look like. So the trick, and I just want to mention that in the web page here, all the things are then specified more in detail in this list here. Did I forget something, Sabri?
I think you followed it well. This diagram is a very good way to explain that. One thing if I would mention would be there are some redundant information that we have been using. For example, we call the file something list.sh, and on the top of the file we mentioned that with the shebang, it's the content of that file is written in bash language. So the computer would know how to interpret it. It would know it's not Python code, it's not R code, but it is bash code. And when you try to run it as a program, the computer says that I'm not allowing you to run this because you did not explicitly mention that this is something I should run. That's also security feature in Linux, however you pronounce it, is that if you don't explicitly say that this is something you should execute and place it, and although it found it in the same folder, it didn't find the file. Some programs like Python might pick up files in the folder, but in this case it didn't. So there are certain like you're building up something to show properly how you would execute a file, how you execute a program. But at the end, maybe you can show the bare minimum you need. You don't need to go through trial and error like that. So you'll give probably a short way to do this.
Yes.
Yes.
We'll see if I answer the question. But the clue is, so as Sabri said, now we showed all the pitfalls that you can go into. You have a file, you don't have permission and so on. It needs to be executable. And we've just gone through here now an explanation of how to see if the file is executable. It should have the X here set. Okay, and it doesn't. So the whole point, if you want to run a file as an executable, you need to make it executable. And that's done with the chmod, change mode, okay? And there's many ways of doing it. You can also use numbers and so on. You can look into that yourself with the man page. But in this case, what we're going to do is do chmod, and plus it means add the X bit and list.sh. And it added it for absolutely everyone, okay? So there's ways of doing it, adding the executable. Maybe only you want to be allowed to execute it. There's options for that. Maybe you want only the group and you to do it and so on. But if you just do +X, you and everyone else will be able to execute that script. And now it's executable, okay? So now let's see if we now can execute it with a ./list. And again, I remind you, the reason why we had to do dot and slash before is to say if the file is here, it's this path here, and then the file name for Bash to know where to search for the file or the executable. If I now press enter, it executes the file. Okay, so before we got permission denied, now it's executing it as we're expecting. And basically, that's it. So if you want to make a file executable, first you have to find out what kind of script it is. If it's Python or Bash, and of course, obviously you will know that because that's what you've been programming for it. And then you have to write bash list.sh if you want to run it. You can just make it executable with the chmod command, and then you can execute it with typing the file name. So that is the way to do it. And then we have some time for exercise. So go ahead and try that. We have 10 minutes now, or 12 actually, until we're done. So, but let's try to use 10 minutes for the exercise. Create a new script called current folder that prints a message with echo, and then the current folder with pwd. So go ahead and try that. Stop talking.
There is one question. I think it's very interesting.
Yes, what's that?
30, question number 30.
When I type groups, 2 groups containing username in the file. Yes. Actually, why there's 2 groups, Danya might be able to answer properly. So this groups command, it's a command that you can use to see what groups you are a member of. And I very seldom actually use the national resources, but Tanya might know, or Sabri might know more better, why there's actually 2 user groups.
I think
I think the Danya, the exact question could be that why there is this username and username _G in a, that's the question I see. Is that correct?
yes, that's I
Yes.
don't know the answer exactly, so
Yeah.
that's why.
So the general explanation is that all the users, they belong to at least one group. So it is their username. So the username. So if you are not if you are have a user account, you should be at least in the group that your username is. Which means if my username is Sabri, I would be member of the Sabri as well.
Yeah, that's a default.
As a default, yes. But on shared resources, the files that belongs to your user group, that should be counted as your user group, could also be found in I don't know, like if you to count under your username, like under your accounting, that's the correct word. So the under your accounting, they have created this username _G. But I don't know, as Radovan also mentioned here, why there's _G. It could be just, but it is to more explain that this is the username and this is the username group.
Yeah,
So
I think that we can
yes.
sum up that is a bit technical reason for it, for kind of keeping a number of files on your quota. And
Okay, yeah. So thank you for today. Thank you for thank you to the instructors who done a very good job to explain in order to explain the things. Thank you for joining us today. And we will have work on the Saga system, submitting jobs and transferring files and everything tomorrow. And you will know better about the what is a cluster and the other details. So before you go for further, before we wrap up, I would like to ask the feedback for the day. Please type your feedback on this collaborative document where we ask questions. As Mike can share one good thing about today and one thing we should improve for the coming days and for the upcoming events as well. Thank you for participating. Thank you for asking a lot of questions. That was very interactive. And I hope you will be coming back to learn a lot about the cluster tomorrow, and we'll have similar or more interaction on the collaborative document. Is there anything you want to say, Maikin or Sabri?
no, just thank you very much, and
Yeah.
thank you for interacting a lot and asking questions. So continue with that also tomorrow. Very good.
Yeah,
and
you will
it
get
be very important for some feedback, Danya.
Yes.
I got to mention, yes.
Yeah, we mentioned it. It is end of the document. You can ask, especially things we should improve next day. That would be very useful for us to prepare afternoon. And you can ask question here as well. And I will archive these notes, but we will use the same collaborative documents for tomorrow as well. But the questions will be archived and linked from this document. Did we test all things we should need tomorrow? Yeah, more or less. You need SSH, the ones who have access to Saga or other machine. If you had problem with user access, I think we need to fix it somehow. Contact me if you have questions. Is there anything they need to test, Sabri, if I mentioned everything?
Yeah, I think it's all covered. See you.
Yeah,
See you
then
tomorrow.
I will ask you to go through this tutorial, especially test how to create files. That would be useful for you handy tomorrow when you create job script and all. Yeah, that's all from my side. And thank you for participation, and especially thanks to all the instructors and those who work behind to answer the questions as well.